Welcome back, everyone, to theCUBE here in Palo Alto, California. I'm John Furrier, your host of theCUBE. This is our Crypto Trailblazers two-day event. Everyone's in town from the Ethereum Foundation in Singapore, are activating Stanford and Berkeley, Cal. All the entrepreneurs are out there. All other thought leaders coming through, sharing their vision and what they're building to usher in this next generation. Marin's here, founder of Nexus. Welcome to theCUBE. Thanks for coming on. We're having a good chat. We should have just turned the camera on before we got on, but thanks for coming on.
Thank you, John. Yeah, it's great to be here. And it's great to be here at theCUBE, as I was saying. We love cubes at Nexus.
Matt Katz was just on. You guys were roommates post-Stanford. Big community here in the Bay Area, obviously. I mean,
high density.
Yeah, very high density of intellectual power, but it's not just tech. You know, there's pragmatic thoughts around how to make money in a new way, the impact around technology. So, you know, again, the movements are happening. Ethereum's been a movement for a long time.
It has.
And stories power movements. And we're so glad you're here to tell your story and also do the commentary and contribute to the community. Tell us about Nexus first, what you guys do. We'll jump in, set the context. Take a minute to explain what you're working on.
100%. It's pretty simple. We have layer 1 blockchain, and we advance zero knowledge proofs. So we work in the field of verifiable computing. So we have a team of a lot of mathematicians and scientists that work, day and night in accelerating this new field of verifiable computing. So Nexus actually started as a research project that I was working on at Stanford. And 2 years later, we're a team of like 35 people here in the Bay Area. Yeah. And it's pretty simple. We actually have a lot of machines that we've put out in the industry. You can think of them as chips. But these chips compute zero knowledge proofs. And zero knowledge proofs are utilized to scale blockchain architectures and bring what we call verifiable computation to life. It's an abstract concept. It's not easy to grab, but verifiable computing is something that allows you to prove whether something is true or false. And that has a lot of applications on many markets. What we say is that we're like an open AI of verifiable computing as opposed to intelligent computing.
So talk about the relevance of that, because in the math, which is, blockchain, there's a lot of math involved, the importance of the proving, we hear proof of stake, everything's about proof, okay? This is the scale piece, because value, store, okay, check, we understand that concept, but this idea of scale and value proofing becomes a huge thing. What's the driver of this? What was the problem to solve? Was it scale? Was it a mechanism? Was it software? What was the main driver?
Yes. So Nexus, we as a company work at a bigger space than blockchain itself, right? Verifiable computing is a new form of computation. And that's something, very weird to say, something like AI or AGI is a new form of computing. Verifiable computing is a new form of computing in and of itself. And just as how AI models like O3, O1, et cetera, can be utilized in many markets, verifiable computing can be applied to many markets as well. So to give you a few examples, human identity. You can prove whether something is true or false about who you are. Private computing, being able to do computations without revealing your private data. High security computing. So if you're part of the defense industry, to be able to show that a computation was done correctly without mistakes. And blockchains are a subset of verifiable computing. They're distributed verifiable machines. And it's well known that, all of the scaling propositions for the long term for blockchains are related to zero knowledge proofs and verifiable computing. And so for us, blockchains is a huge industry, financially speaking, that we target.
So it's a segment for you.
It is a segment.
So you brought up AI, so I want to kind of maybe make a comparison and get your reaction to. If you look at Nvidia, okay? Nvidia was doing gaming, they were a graphics card.
Yeah.
I mean, now they're bigger than Intel. Look at the stock price.
It's crazy.
They started as a graphics card, all the gamers used it, and they became systems for gaming. Crypto, great part of mining. I mean, Nvidia, thank you Nvidia, thank you for the blockchain enablement. Then they go to AI, and now it's the supercomputing revolution.
Yes.
Okay, so, Jensen Huang talks about accelerated computing all the time. With that kind of paradigm, compare what you guys are doing, because I see a little bit of comparison here.
100%.
With what you're doing. You're accelerating, you're verifying, which is actually, I'm just riffing on this, but like I can see because he talks about accelerated computing as a paradigm. Okay? and it's a new thing. It's a category.
It's a new category that they're building.
Better compute. And now
It's
you
a
got
different type
now
of
you got AI factories. So to compare, how would you talk about what Nexus does if it was a categorical shift as equivalent verifiable computing? Obviously, there's some acceleration in there, but not in the sense of GPU. But like, talk about the comparison. How would you frame that?
Yes. So there's two verticals there. You can think about it as like the Nvidia of verifiable computing. So not computing, but verifiable computing. And we actually ship machines. We've shipped 4 machines. We call them CKVM. So we've shipped CKVM 0, CKVM 1, CKVM 2. Last week we shipped CKVM 3. These are verifiable machines like verifiable chips that get better and faster on each iteration. Our latest machine was about 1,000 times faster than our version 2, which was about 100x faster than our version 1, which is about 10x faster than our version 0, which we presented at Stanford about a year and a half ago. So these machines actually get faster and faster and faster at generating these proofs. Now, the other side of comparison with what you just described is we happen to be building a supercomputer. You know, if you go to our website, we talk about the supercomputer here and there. This is very serious. We're attempting to build the world's largest distributed supercomputer to ever exist. And how is this related to, you know, these chips that we put in the market? These are virtual chips, by the way, not physical chips. You know, we have machines work together as one to compute as a single machine. In fact, we were inspired by Ethereum back in the day. You know, world computers. We can talk about it.
Let's go through the use case. Layer 1 supercomputer. I love that concept.
Appreciate it.
I love your website, planetary scale. Mars is coming. We'll get to that in a second. No, but I mean, talk about the use cases. Who's the customer? Where's the needle moving moment? What's the vision? Is it faster blockchain? What other markets do you see? Because you have the supercomputing.
Yes.
You're going to have the ability to power stuff.
Exactly.
Is it efficient with power and cooling? What's the power envelope look like? These are all questions that are jumping in my head. I'm kind of going off the rails here a little bit.
Totally. So it's actually pretty simple. Like our team invented this new thing, these chips, this zero-knowledge virtual machines, CKVMs, that allow you to prove whether something's true or false and use this insane mathematics. And so with this, you can do many things, including asking from the ground up how to build a blockchain. And it happens that with these things, we can build a blockchain by utilizing idle compute around the world. So for example, the computer that you have right there, or your phone, they have compute that is not being utilized. And we can tap into that compute and pay you for that idle compute so that your computer can power our blockchain system. So we have built a blockchain and are building a blockchain that gets more and more powerful with the more and more compute that is connected.
So exponential scale. You got kind of a grid, I mean, back, and not to date myself, but grid computing was a concept.
Yeah, it's related to that.
Back in the day, the more you put on the network, the more powerful it becomes.
Exactly.
With all the benefits of, like the internet.
Exactly, the huge network effects. So in our case, this is what we call like the first blockchain supercomputer out there. And it's possible because there exists like this brand new technology, which is the CKVM, that requires a lot of math and cryptographers. But it can scale exponentially through 2 verticals, vertical scaling and horizontal scaling. So vertical scaling is the chips and the technology getting faster and faster and faster, which are our series.
By the way,
of CKVM.
AI loves vertical scaling. Because domain expertise.
For example.
GPUs.
That too.
Well, that's just everything's in vertical, but then the horizontal.
It's just more compute.
Yeah.
Right? And so the product of the 2 is how powerful the system is. And so our blockchain is designed to capture the exponential effects of Moore's law. But it's a new form of Moore's law, a new form that only applies to verifiable computing.
Okay, I got to ask, because were you guys sitting around saying, or where was the moment that this kind of clicked for you? Obviously, you got the research, you went to Stanford, you get the brain trust, you got the network of folks working on a lot of cool stuff, the density here in the Bay Area, super powerful. What was the motivation? Was it like Eureka moment? Where were you? When did it come together? When you say, hey, we're doing this? Or was it an evolution to a flashpoint?
Good point, good point. I would actually say it was a little bit of a Eureka moment, but it sort of built to it. You know, I was part of the Stanford Blockchain Club. I was a student of cryptography at Stanford. Before that, I studied like theoretical physics and mathematics. And so at one point, I was working on my senior project at Stanford. And a new paper came out from Microsoft Research, actually, that showed how to combine zero knowledge proofs together. So you could grab a lot of proofs, compute it for some programs. You could all combine them into one. If you extrapolate that idea, you can realize that you can have, for the first time in history, a lot of computers work together and combine their computer output into a single output. And so the goal of Nexus from day one has been to build this supercomputer system by combining all of this computing power into one. And that's why we sometimes call it the Nexus project, right? So even though we're a Delaware C Corp, we're a startup, et cetera, our goal is to build this gigantic computer system that our hope is outlasts even our lives.
Yeah, I mean, you're at the Nexus, pun intended. And you mentioned AI. I want to bring that in because you mentioned horizontal and vertical scaling, which, you know, from a hardware standpoint, layer one, and the physical layer and gear.
Exactly.
Software's got to run on it, right? So you need software to run on hardware. Not to go old school. You got hardware, middleware, apps. Okay, that's the old school kind of breakdown. If you're going to nail down this layer one, supercomputing, okay, love the vision, love the execution there. Now, what happens next? Because now if you intersect AI, some of the things we're talking about AI, you mentioned it a little bit earlier, you now have a runtime, a generative process. So runtime assembly is not a new concept in distributed computing.
Totally.
I mean, it's been around for operating system theory, you know, link, load, everything happen, compile. But now with generative AI, the category, it's generating new things. It's not pre-programmed. So this idea of the proofs coming together makes me think there's got to be an intersection, the nexus between some of the AI advancements.
100%.
Can you share your vision on that?
Yes, the vision, there's so many intersections that we can spend a lot of time talking about. But something that I like to say, I'm a technical founder, right? We as a company are a very practical company. The technology is just an element for what we think is a huge business opportunity that's coming in the next years and decades. The layer one blockchain that we've built is only, as you said, the runtime for what we hope will be many world-scale applications, right? And businesses getting a lot of distribution power. And so answering your question about AI, we are in San Francisco, the epicenter of AI. We're literally like a layer one blockchain company surrounded by a bunch of AI companies, right?
You have a lot of friends.
We do have a lot of friends.
Supercomputing, hey.
Exactly, on GPUs and high performance computing.
First drink is free, you know?
Something like that, right? Something like that. And so something that I was just chatting with someone yesterday is like, we expect that 99% of users on the Nexus blockchain will be AIs, actually, just because 99% of software and backend system is being written by systems such as Cursor and, you know, Copilot, and then you can have agents trade with each other, so on and so forth. And so answering your question once again more concretely, AI forces advancements in compute performance that directly benefit the Nexus layer one blockchain because it was designed for that. AI allows us to do way much more trading, let's say, on the blockchain than before. AI allows us to deploy applications way faster for blockchains than ever before. And for a team like us, which is like a lot of high density in terms of talent, when we give access to, you know, AI tools to our teammates, we're able to develop applications, you know, at 10x the speed that we were before. And so, taking a little bit of a macro perspective, AI nowadays is pushing the world to move so fast at an exponential rate that if you are a startup that is capturing a market, you need to be thinking about how do I keep up with the velocity at which things are moving, and how do I utilize this exponential momentum to build a company that scales, well, to the scale that you want.
You know, one of the things I love, I've been in California, Palo Alto for 25 years, and studying entrepreneurship by living it and hanging out here, is that it's serendipity, the propensity for collaboration. And when you have collisions of people connecting, whether they're roommates or whatever, just sharing is interesting.
100%.
And so now we're at a point where, okay, you have two worlds colliding in a positive way where there's a lot of propensity. So open source software, where the AI friends, your AI friends are hanging out, new models are leapfrogging each other every day, but also how to use off-the-shelf stuff to make it go better. So you're seeing a whole top of the stack, if you will, middle of the stack, get innovative. You got the supercomputing vision here, scaling from the bottom. As that comes together, I'm expecting a lot of the problems we solve. So here's what we know. We love AI. We know there's problems. Power, cooling, energy, bounded by energy. I mean, AI is bounded by energy at some level. Data centers are sold out. I mean, CapEx, looking at nuclear reactors. So in every wave I've seen, the so-called standard, like Ethernet, it's dead. I mean, it dies every year, but it never dies. So now it's the center of the fabric in chips. The role of standards are key. Things evolve and problems get solved. What do you see as problems that solve if you take your vision forward? Because you have efficiencies.
Certainly.
Okay. That's a potential power opportunity to solve that problem.
Yeah.
One. AI wants more horsepower. They want more context. You see what DeepSeek does. I mean, it's very clever. I mean, that's just an illustration that smart people can figure stuff out.
Yeah.
What do you see as stuff that will be figured out? If you kind of connect the dots a little bit, go out to the future and say, what will be solved by evolution? Interactions with people, creativity, entrepreneurship, collaboration. What are some of the things you see will easily be checked off the box?
Well, ultimately, you know, all of this technology, et cetera, it's all meant to enhance human superpowers, right? AI enhances human intelligence and productivity. Blockchains enhance financial superpowers of businesses. And so to give you an example, and I think a lot of blockchain people don't talk about this too often, is if you are a business and you're utilizing a blockchain, you get access potentially to millions of users. You get a lot of distribution power. You gain the ability to raise capital from many parts of the world. You gain the access to millions of users to pay you instantly from everywhere, right? And so if you're a developer and you know how to utilize AI and blockchain, you gain both technical superpowers and financial superpowers that allow you to build a business with very little resources. And it's pretty insane.
I mean, you have a back-end innovation theater going on, front-end innovation theater.
Exactly.
I mean, SaaS was just front-end in my mind. That was just web apps on the cloud. Cloud was a back-end innovation, but there's no front-end innovation. It was just SaaS on the cloud. Both created massive change. Now you have two theaters of innovation
that are happening
at the same time.
Exactly.
I've never seen that.
It's crazy times. It's crazy times. What I tell, you know, when people ask me about, hey, you know, what's coming is like, the human mind cannot comprehend exponential effects. If you're a company leader, you need to understand that exponential effects are happening whether you want it or not. So how do you best position your team to be able to capitalize on those rising technologies?
Daniel, I really appreciate conversation. Great innovation. Congratulations. Looking forward to seeing how it goes. Put a plug in for Nexus. What are you guys looking to do? What your goals are? Share some stats. Just take it away.
Totally, 100%. Well, since November, over the last something like 8 months, we've launched 3 global testnets, right? Our first testnet had about 100,000 users. Then we had about 500,000 users. We just launched a testnet, our third testnet, about 2 weeks ago. It had about 2 million users. And out of that, there were like 3.5 million nodes running our software in the network. And so, you know, what's next for us is probably one more testnet release, and then likely mainnet. You know, still to be determined. But we are a team that is very focused on shipping constantly and very fast.
Well, congratulations. Love your work. Love what you're doing. How do people get involved? How do they engage with you guys? Give the coordinates. It's all yours.
So the magic of Nexus is that you can join quite literally in just one click, even from your browser. If you go to nexus.xyz and you click connect, you already start supplying compute to the network. And you join the
I got like 3 Macs sitting around and a Dell, and I'm going to just click it up and join the supercomputer hive mind of infrastructure layer 1. I guess it's like a hive mind of layer 1.
It is.
You know.
It is like a hive mind.
Daniel, thanks for coming on. Great conversation.
Appreciate it.
Of course, the crypto trailblazers, blazing the trail, plowing the fields, creating innovation. Again, not for the faint of heart, but as the breakthroughs come, mainstream, continues to adopt. You're going to see a lot more distributed computing architectures, blockchain, new kinds of applications all coming to the table, all from the Trailblazers here on theCUBE and beyond. I'm John Furrier, host of theCUBE. Thanks for watching.